Hey guys, welcome to Conceptual Geometry, Lesson 3.5, Properties of a Rhombus. Before we get to our note packet, I'd like you to take out your blue shape packet and flip to the rhombus. All right, we're going to do a little discovery here on the properties of a rhombus. Now, unfortunately, I can't show you this up on the front board, but I can use the straight edge or the ruler that I have with me. You can't see that, however, but I'm just going to measure the four sides. Now, after I get the first side, you can probably predict, that's 120 millimeters, you can probably predict what all of them are going to be. So I measured side DC, I got 112 millimeters, and CB also 112 millimeters, AB 112 millimeters, and obviously DA is 112 millimeters. So what I've just done here is I've shown you the most important property or defining property of a rhombus, and that is all four sides are equal. Well, you're probably more familiar with a square, which we'll talk about in a few days, but a rhombus doesn't necessarily have to have right angles. So if you notice here, I measure with the protractor, and that was approximately 60 degrees. Angle B is also 60 degrees. C, as you guys can guess, was 120, and so was A. So as long as the shape has four equal sides, that's what makes it a rhombus. So what I'd like to discuss next are the diagonals, because the diagonals are what are really special in a rhombus. So first, let me sketch these in. All right. So there's diagonal DB, and here's diagonal AC. So first of all, I think it's obvious they're not congruent by any means. AC is much smaller than DB. But one of the special properties about the diagonals of a rhombus is that they are perpendicular. So all of these are right angles. This does not happen in a rectangle, does not happen in a parallelogram. Another really cool feature, let me show you this first. They do bisect each other, so those two pieces are congruent, and those two pieces are congruent. But what's really special is that they bisect the angles. So these two angles here are equal. Those would both be 30. And same thing on the other side. Those are both 30. These two angles here are equal. And they're both 60. Half of 120. Same thing down here. So what's really cool is notice this triangle here is a 30, 60, 90 right triangle, and it's the same as this one, which is the same as this one, which is the same as this one. So basically the diagonals create 1, 2, 3, 4 congruent right triangles. So it's really easy to find all the missing pieces once you are given one of those missing pieces. Okay. Let's talk about the properties of a rhombus. Number one, opposite sides are parallel. 2, opposite sides are equal. 3, opposite angles are equal. 4, adjacent angles are supplementary, so they add to 180. And 5, the diagonals bisect each other. Now that should all look familiar to you guys because those are the properties of a parallelogram. So a parallelogram, a rectangle, and now a rhombus all have those 5 properties. What distinguishes a rhombus is that it has additional properties. Okay, so the first thing we talked about, 4 equal sides. All the sides are equal. So in this shape right here, we can define that. We also know opposite angles are equal. We can put those in. Next, the diagonals are perpendicular. We're going to start using that symbol a lot more. So that means these are all right angles. Every rhombus. And finally, the diagonals bisect the angles. So that means angle 1 is congruent to angle 2, is congruent to angle 7, is congruent to angle 8. Angle 3 is congruent to 4, is congruent to 5, is congruent to 6. So what I like about a rhombus is that it has, I would say, perfect symmetry. Look, it's got symmetry up and down. So all of those angles are equal, and the ones opposite are equal. It's got symmetry left to right. Those and those. So that's what makes a rhombus really easy to work with. So what does a rhombus always have that parallelograms or rectangles do not necessarily have? 4 equal sides, perpendicular diagonals, and the diagonals bisect the angles. Okay. So we're adding those 3 very important properties to a rhombus. Let's try a couple examples, and then I think we'll pause for day 5, and we'll finish up with day 6, and you can do a delta math for day 6 as well. First example, given rhombus ABCD. All right, so here's a rhombus. What I like to do right away is realize, oh, hey, rhombus, all 4 sides are going to be equal, so I'm going to mark those. Also, diagonals are perpendicular. So that's one of the first things I do anytime I'm given a rhombus. Next, it says, find measure of angle AEB. AEB, oh, that's one of those angles in the middle. It's perpendicular, 90 degrees. Easy. Next, if the measure of angle DAB, so that's this whole angle right here, is 130. So that whole angle is 130. So remember, the diagonals bisect the angles. That means this angle 1 and that angle right there are going to be the same. Together, they're 130. So I need to take 130 divided by 2. That's going to be 65. So both of these angles here are going to be 65. I don't need angle, the other one on the other side, but angle 1 is 65 degrees. So now how do we find angle 2? Well, this is 90. That's now 65. This is a triangle. So these 3 angles have to add up to 180. So to find this missing angle here, I'm going to take 180 minus 90 minus 65. 180 minus 90 minus 65. That's 25 degrees. And when we're done, it's easy to check. These 2 need to add to 90. Right? Why is that? Well, because this angle plus that angle plus 90 have to equal 180. So that's a good way to check it. One more example. All right, in rhombus ABCD, if the measure of angle DAB, so let's trace it. It's very similar to the one we just did. That angle right there is 150. Find the measure of every other angle. So that means it wants every single angle in this figure, which is not hard because remember what we said. Rhombus has perfect symmetry. All 4 of these triangles here are going to be exactly the same. So basically, you just need to find one triangle, and then you know all the other ones. Okay, so again, this whole angle is 150. So that angle right there is going to be 150 divided by 2. That's going to be 75. So let me fill that in first. Well, if that one's 75, this one here is 75. Remember, a rhombus has perfect symmetry, so those 2 over there are going to be 75. Another important part of a rhombus is to recognize the diagonals are all perpendicular. So each one of these is going to be 90 all the way around. So let me fill that in. 90, 90, 90, and 90. And then lastly, I know these 4 angles are all going to be the same. You just need to calculate them. Well, you just have to look at one triangle That's 90, that's 75. So to get this angle here, I'm going to take 180 minus 90 minus 75. All right, I believe that's 15 degrees. So all the rest is going to be 15 degrees. So pretty cool. Again, check out the symmetry, right? This one triangle here is a 90, 75, 15. 90, 75, 15. 90, 75, 15. 90, 75, 15. So all four of these triangles are the same. Okay, well that's good enough for day 5. We'll continue with example 3 and the rest of them on day 6, and then you can do a delta math homework for that day. But day 5, there's no delta math. You just have to make sure your notes are filled in. All right, guys, thanks for following along, and we'll see you in class soon.